what if I say this is u and this one is v, and we can apply the product rule here.
Yeah.
So what is stopping you to solve this question? It is quite easy. For this part, the derivative v is gonna be the same thing, and for the u, it's gonna be the u derivative is gonna be 6x minus 5. You just plug in the values in the product rule, that is uv plus u and v, right?
Yeah.
You just plug in the values and just simplify them. Okay?
Yeah.
Yeah, I think
Get
that,
it.
yeah, it's not a big deal now, because you have worked all through the basics now, and
Yeah.
it'll be easier for you to work with them. So it's the same thing here. So for this part, you can apply the quotient rule. Okay? Yeah, where there is a quotient line, apply the quotient rule.
Of course.
And yeah, it's just a glimpse that that's going to be our the ultimate task, that we will see that if we are good with the maths for now or not. And mostly they might seem trickier, might seem cumbersome, but they are just the application of these rules. The only thing that you might need to work on is to simplify them so that you can apply the rule. Okay, so you go either for the product rule, like the product of two functions, the division of two functions, something like that. You don't worry about it.
Something like,
yeah, for this part, it's for the f of like the 14. How would you attempt it?
by doing quotient rule?
Yeah, you can do the quotient rule, but that would be a lengthy solution. Is there any shorter solution like you can do that with the
Probably we can just bring it all up to the top. Is that what you're saying?
Yes.
So it would be 2x and negative 3, negative 6x and negative squared, and then
You cannot take the numbers here, by the way. You cannot take the whole numbers there.
sorry, just x negative 3.
Yeah, let me see. I haven't solved that question now, but let's try what's going to be the easier way to solve it. So one way is to solve it is like if a over b plus c plus d. This is the general form of this equation, by the way. One way is to solve it is like a over b plus a over c plus a over d. Yeah, we can write this like that. Or the other way is to consider it as a factor and take the whole factor to the numerator. Yeah, it's gonna be like b plus c plus d, the whole power is minus 1. This is another way to solve this question. But unfortunately, we have the coefficients here. So we are gonna do it is as 1 over 2x power 3 minus 1 over 6x squared plus 1 over 5. And now we can take the variables to the top, and that's gonna be 1/2 x power minus 3 and 1 by 6 x power minus 2. And it's gonna be the constant term here. That's gonna be eliminated, by the way, when we take the derivative. So
I see.
yeah, so I think now we can apply the power rules, right?
Yeah.
Yeah, it's easier now. Or b thing is it's a cubic form, we cannot factorize it right away. Yeah, this is the way, I think, the only way to solve in an easier way. Or the hard way could have been we consider one as the u and the cubic form as v, that is u is 1 and v is 2x cubed minus 6x squared plus 5, and then we apply the quotient rule. You see, it's going to be quite difficult to solve this easier question in a long, lengthy way. So I think that's how we solve this question here, right? So it's
Yeah.
gonna be a lot of multiplications here, a lot of scales here involved, and there are the chances that we're gonna miss some power. And so I would not recommend the quotient rule here for this part unless it is instructed that you have to apply.
Yeah.
Then we surely have to go for this harder way. But rest of it, we just go for the simplification by the power rule. Okay. So, so next time we are gonna review some chain rule. How and why do we need it? And
Yeah.
The implicit functions, the differentiation of implicit functions. That's gonna be our new two topics. And after that, I think we would just go for some graphical ways. Okay, so Connor, have you got the answer? If we don't want to apply the product rule, can we solve a function without applying the product rule?
Yeah.
Yeah, that's simplifying them first and applying the power rule. Okay. So, did you have any other question for me?
Not really. I think that makes sense.
Okay. So once we complete the derivative part, we will go for the integration part. After that, it's almost the same thing, but in the reverse form. It's
Okay.
it's just like you take the square, and then you take the under root. It's just like you take the derivative and then you take the integration, and you come back to the same point that you have started with. Okay. So, Connor, have you made a formula sheet for the things that we have studied?
Not really.
Yeah, I think you should start writing one
I mean,
page.
all the formulas we have right now is just the quotient rule, product rule,
Yeah,
power rule.
and the little things like the what do you call the laws of indices, laws of exponents. Just write it'll just write four or five of them, and the like let's say you can write x power 0 equal to 1. These little things help you a lot. So I would say just take one piece of paper like A4 size and
Yeah.
start writing the formulas only, the crux of the whole session only. It would be like a half page maybe we have covered so far. Okay. So this way, if you want to go for your exam, you don't have to go through all your books. You just go through your like formula sheet and you just memorize and try to recall the important things only, and then you just apply them.